Welcome back, fellow tech enthusiasts. Today, we're diving deep into the fascinating world of web security. Buckle up, because we're about to explore a mind-blowing vulnerability that has been lurking in the shadows for far too long, CORS with trusted insecure protocols. Hey there, folks. As always, I've already added the URL to the scope and hidden any out-of-scope items. But what's really cool is that we've taken it up a notch with advanced scope control, ensuring we cover all subdomains. So, no stone unturned. We can now log in using the provided username wiener and the password Peter. And now, we can see the API key for the wiener user, which is in the response of the GET request to the account details. Alright, folks, let's get this right. It's time to send the request to the repeater and have some fun playing around with the origin request header. Remember, it's all about exploring and experimenting to see what works best. So, it seems like the same old https://test.test and null just aren't doing the trick. Let's give it a shot with the subdomain, which is https://test.0a58 blah blah blah.com. Ah, there you go, it works. It's in our beloved access control allow origin response header. In this case, it appears that the CORS is correctly configured, allowing a trust relationship between https://0a58.blah.com and its subdomains like https://test.0a58.blah.com to be established. However, if a website trusts an origin vulnerable to cross-site scripting (XSS), an attacker could exploit the XSS to inject JavaScript using CORS. This would retrieve sensitive information from the site trusting the vulnerable application. So, let's hunt for any subdomain that may be vulnerable to XSS that can help us to access the API key at the account details page. In this case, the stock checking functionality seems to be accessing a subdomain at http://stock.0a58.blah.com. Let's send the request to the repeater and play around with parameters to see if it's vulnerable to XSS. So, what we've got here is a situation where the JavaScript injected at the product ID parameter appears to be completely reflected in the response. Let's test the payload in the Burp browser, and voila, there it is, the classic pop-up. We'll then test whether the URL https://stock.0a58.blah.com can access the API key on the account details page of https://0a58.blah.com. Let's take the same script and put it into the product ID parameter. We need to URL encode all key characters, making them in one line. The reqListener function serves as the callback mentioned in line 2. Once the response from our vulnerable website, containing the API key, arrives, this function gets triggered. Within reqListener, this line redirects the location to a new URL, including this .response text the data from the vulnerable site. This leads the user's browser to our exploit serve. Righto, let's get cracking and fill in our account details page over at https://0a58.blah.com. Alright, mates, now that the script's all sorted, it's nicely in one line in the product ID parameter. Beaut. Now, let's fill in the URL of our exploit server, It's a .ul, really. Just pop it in, and we're good to go, cobber. No worries, we're nearly there. The script looks all dandy and printed in the response for the stock check request. Now, it's time to take the Burp browser for a spin and test that payload, shall we?
Request access code.
We can now grab the API key of the wiener user from the access log. Don't fret about that 404, we'll deal with it later, no dramas. Now, let's move on and prepare our exploit, right? It'll cleverly redirect the poor victim to the stock checking subdomain, packed with an XSS payload. And, guess what? That payload will find its way to our exploit server, as per usual.
Request access code. Access denied. Enter override.
Now we can store and check out the exploit. Have a squiz at the access log, and bingo! You'll spot the API key of the wiener user. Time to head back to the exploit server and dish out that exploit to our unsuspecting victim. Now, reckon we've got ourselves an API key lurking in the access log from the administrator user? Well, crikey, seems like Lady Luck ain't on our side this time. It's a no-show in there, mate. Let's attempt to redirect the victim to http stock.oa58 blah blah blah.com instead of the https one. Let's give it another go to the poor bloke, yeah? It seems like the API key is here after changing the protocol from HTTPS to HTTP. But, when we try to access HTTPS, stock.oa58 blah blah blah.com, the redirection works, even as we view the exploit in the Burp browser. My best assumption is that the stimulated victim is set to use the HTTP protocol. This is somewhat indicated in the lab's title, CORS Vulnerability with Trusted Insecure Protocols. Anyhow, feel free to share your thoughts with me. We can chuck in the decoded API key to wrap up the lab. Catch ya next time, mate.